So we're going to use problem solving to use coordinates. Our objective is to use algebra and geometry to solve coordinate proofs. This is a chart explaining how the algebra and geometry work together to solve the problem. So now we need to label these points given a shape with variables so we can use algebra to solve. So the point D, I could call point D, it's the distance over, we could call it A. Its distance up is 0, so that's A0. Point B, it's 0 over, and we could call the distance up, we don't know it's the same as the distance from A to D, so we'll call it B, 0B, right? Then point C is A over and B up, so we'd call it point AB, right? That'd be labeling the points for a rectangle. In B, we have a parallelogram. So I'm going to call, we'll call point D A0. We'll call point, what can I call point B? What can I call point B? Okay, well, it's not this distance of this line here is A, but the coordinates of that point, you know, that's the hypotenuse. We need to know the x distance and the y distance, so those are unique. So we call that B and C. And then point C, we've got B. What could I call the x value of point C? Sam? No, we would call it A plus B because it's this distance is A, right? And then this distance here, since it's a parallelogram, we know that this distance here would have to be B. From here to here is B. So that's A plus B. C. All right. All right. So some tips when doing these coordinate proofs. 1. Assign appropriate coordinates to the figure as we have done. You want to make it as general as necessary. So, you know, like with a parallelogram, you don't want to assume that the sides have the same length and that type of thing. If we plan to prove a theorem about triangles in general, we should not draw a special case of a triangle such as a right triangle or isosceles triangle. Placing sides on the coordinate axis and using 0 for as many points as possible will often simplify calculation. So, don't draw the special triangle, just draw a regular triangle. 2. Use assigned coordinates to write a proof. Some tools we have. We can use slope. If we want to show segments are parallel or perpendicular, we can plug in the values for the variables of the points and use slope. We can use the midpoint formula to show when segments are bisected. Distance formula for showing segments are congruent. Line of equation, an equation of a line to show that points intersect. So here's some examples. Use the coordinates to prove that the diagonals of a rectangle are congruent. So what you need to do is you need to draw a coordinate axes and put a rectangle on it. We'll call this point A, it's 0, 0. Point B is 0 over B up. Point D is A0. And point C, as we did before, is AB. Right? So we now we need to show that AC is congruent to BD. Right? So I'm going to find the distance of AC. AC, I do the distance formula on the coordinates for AC. We would have the square root of A minus 0 squared plus B minus 0 squared. So that's going to equal to the square root of A squared plus B squared. All right. Then we do BD. BD is equal to the square root of zero minus A squared plus B minus 0 squared, which is equal to square root of A squared plus B squared. Right? So that shows that AC equals BD. Any questions? No questions there. Okay. Now, we're going to use coordinates to prove the diagonals of a rhombus are perpendicular. So we're going to draw a rhombus. So I draw my coordinate axes. And I'm going to make a rhombus with one of its sides coinciding with an axis. Let's make it one of its sides coinciding with the x-axis. So my rhombus could look like this. Right? So if we label our points, A would be 0, 0. We could call B AB. Right? And we could call D C over 0 up, C0, and then point C would be A plus C and the distance up would be B, A plus C, B. Now, so there's two things I'm going to use here. I'm going to use Pythagorean theorem, and I'm going to use perpendicular slopes. So the first thing we've got is this makes a triangle here, from here to here to there. That's a right triangle. Okay? And in that right triangle, we have, we know that the x value, this is A, this distance is A. The distance up is B, and the hypotenuse is C. Right, so we can say A squared plus B squared equals C squared. Right? In our triangle there. So now, second, why don't you just stay in here since the period's almost over. Second, we need to show that AC is perpendicular to BD. So we can do the slope of AC, M of AC, is equal to B minus 0 over A plus C minus 0. So that equals to B over A plus C. Then we do the slope of BD. Slope of BD is going to equal to let's see, B from B to D. We're figuring out these slopes. B to D. We could say it's B minus 0 over A minus C. Which is equal to B over A minus C. Now we have to multiply those two slopes together to see if they equal -1, right? So we would do B over A plus C times B over A minus C, and that's going to give me B squared over A squared minus C squared. Now, from our Pythagorean theorem here, right here, okay, this right here, from that we can say, it's getting kind of crowded here, but we can say that from that we can substitute in for B squared. B squared is going to equal to what? What does B squared equal from this equation? What would it equal? Yeah. Right, so we're going to substitute C squared minus A squared in for A squared minus in for B squared, and then put that over the A squared minus C squared, and that equals -1. So we've shown the slopes are perpendicular. Alright, so you can use the right triangle Pythagorean theorem to substitute in for a squared value. So then in the end, we would conclude, therefore, because that equals -1, I could go up here with my conclusion and say we have AC is perpendicular to BD. Alright, any questions? No questions on that one. Okay, we've got time for the last one then. Everybody have this? Alright, so on this last one, use coordinates to prove that any quadrilateral ABC whose sides have points W, X, Y, and Z as shown, show that that's a parallelogram. So the first thing I need to do is take this shape and ABCD and get it so one of its sides coincides with an axis. So we will we'll draw our coordinate axes and we'll rotate this shape so that we have we've got this. It's going to look like that. We'll call this is point A, this is B, this is C, and this D. Alright, so A would be 0, 0, B would be AB, C, it's going to be different. It doesn't have an X value of A or a Y value of B, so it would be, we could call CCD, and then D, we would call it E0. None of the points are going to be the same distance from the X or Y, because it's just an odd-shaped it's not an odd-shaped figure. It's not a parallelogram, it's not a rectangle or anything like that. It's just a regular old quadrilateral. Now we've got the W, X, Y, and Z. Right? Those are, it tells us that those are the midpoints. So if those are the midpoints, we need to find their coordinates, right? So for W, we'd find the average of the A value, the point A and B values, right? So W would equal to A over plus 0 over 2, B plus 0 over 2, so it would equal to A over 2, B over 2. X would equal to A plus C over 2, B plus D over 2. I average the Y value, so that would equal to, so that's X. Y is going to equal to C plus E over 2 and D over 2, right? And Z is going to equal to E over 2, 0. So I found the coordinates of all those midpoints. All right, now to show it's a parallelogram, that WXYZ is a parallelogram, I've got to show that WX has the same slope as ZY. These two, we've got to show these two lines are parallel. So I can take these points I've found, I'm going to clear this out, you'll have it on your paper to refer to, but for my slope, we need to go back. For my slope of the slope of WX is going to equal to, so I take the difference of the Y values for W and X, that'd be B over 2 minus B plus D over 2, and we'd put that over the Y values, A over 2 minus A plus C over 2, so that's going to equal to B minus B minus D over 2 and A minus C over 2. That equals to negative D over 2, negative C over 2, which is equal to D over C. Right? D over C. Now we do the slope of ZY. Slope of ZY is going to equal to D over 2 minus 0 over C plus E over 2 minus E over 2. So that equals D over 2 over C plus E minus E over 2. And that equals to D over 2 C over 2, which is equal to D over C. So, these two slopes, this slope and this slope, are the same. So from that, because those slopes are the same, make sure everybody has that. Anybody still writing? Everybody have everything written down? Okay, so because those two slopes are the same, we can say that it would follow that we would have Wx is parallel to Zy, and similarly Wz is parallel to xy. So Wxyz is a parallelogram. All right, any questions on this section? No questions. All right.